Hello everyone. Today I'd like to talk to you about a central problem in business calculus dealing with maximizing the revenue, and I'll show you where that is in your notes. It's right here. So this is the second page, see at the bottom, second page of your quadratics functions notes, and you should have this in front of you, so I won't leave it here. It reads, if a car dealership sets the price of their cars at $28,000, they'll sell 54 cars. Every time they drop the price $1,000, 2 more cars will be sold. What should the price of the cars be set at to maximize sales? So they've given us information, groupings, and they're saying that $28,000 is the selling price when there are 54 cars. So if they drop the price, so if the price goes down by $1,000, so that'll be what, 27,000? Then they will sell 2 more cars. So the cars is going to go up by 2 cars. So this will be 56 cars. All right. So one way to think about it is to try to consider the relationship in a graph. So here we have 56 cars. Correction, I'm going to start off with 54. And right here we have $28,000. And this is your selling price. Okay, so here's one point. And they're saying that if you do 2 more cars, so you're at 56, then you will drop the price by $1,000. So that's $27,000. Okay, so hopefully you could see that this is very linear. So right 2 down 1,000. So if we connect these dots, then we're trying to find out the equation of the line that goes through those 2 points. All right, so something that is really important to keep in mind is that oftentimes in the problems that you're given in Math 121, you are forced to put your quantity in the X and your price in your Y. All right, so you're going to have to keep that in mind, because it's very likely that I will say somewhere in the problem, find the price in terms of the quantity of cars, or find the price as a function of the number of cars. So I'm going to force your hand where quantity has to go in the X and the price goes in the Y. All right, so here that means that we have 2 points. We have 54 and 28,000. And we also have 56 and 27,000. Okay, we would like to find this relationship, this linear relationship between the quantity and the price. Put a line there. Okay, so as I mentioned, in order to find the equation of any line, you need a point, and we have 2, and the slope. All right, so let's get to that. So your slope is simply just 28,000 minus 27,000 divided by 54 rather, minus 56. So this equals 1,000 over -2, or your slope is equal to -500. Like that. All right, let me move this so that you can see a little bit better. All right, so if we want to find the equation line that's running through those 2 points, most of you are probably going to think, oh yeah, I'm going to pull out y equals mx plus b. The problem with that is that everything needs to be placed in context. So we're going to take this y and we're going to go back to our points and realize that the label in the y position is the price. So you want to be careful to acknowledge that. Everything needs to be placed in context. So this should be lowercase p. I put a tail on my p's right here to indicate the lowercase. Lowercase p of x equals mx plus b. All right, now let's plug it in. So negative 500 here. It doesn't matter which 2 points you use, so 54 here equals 28,000. Let the plus be there. So I get 28,000 equals negative 27,000 plus the b. So you're adding 27,000 to both sides. So then 55,000 is equal to b. All right, so let me put all of that together. And when I do, I get that p of x equals, my slope was negative 500, x plus 55,000. Alright, so please keep in mind this basically gives us a sliding scale, because the more cells you get, the lower you're able to make the price for each one of your cars. So P of 3, for example, would be the price at 3 cars, right? So plug 3 in, negative 500 times the 3 cars plus 55,000. Okay, that would be the price for those 3 cars. If you did P of 10, then you would put 10 in for the x's. So negative 500 times 10 plus the 55,000. Now P of x says this is the price of x cars, would be negative 500 times x plus 55,000. So again, I want to make this distinction because it'll come in handy later. This is the price of x cars. Alright, so that is the first part of this revenue problem.